All right, this is the AP Calculus AB 2016 free response solutions. So we're up to number 5, and this is the problem. It's a problem about this funnel. And we're in a non-calculator section. And you can read through the problem, but the basics are we've got this funnel. It's circular. Okay, that's going to come into play. And the relationship between the radius and the height is described by the radius is 1 over 20 times 3 plus h squared when the height is between 0 and 10 inches. So part A says find the average value of the radius of the funnel. So to find an average value, right, it's 1 over b minus a, and then you integrate from a to b. And in our case here, it would be r of h dh. Okay, so that's going to be 1 over 10 minus 0, so 1/10, 0 to 10. And we've got 1 over 20 times 3 plus h squared dh. Now you need to write all this out properly. Let's bring that 1 over 20 out front. So that'd be 1 over 200 now. 0 to 10. 3 plus h squared dh. So we're going to have to integrate this by hand. All right, so that's 1 over 200. That would be times 3h plus 1/3 h cubed. And we are going to evaluate that from 0 to 10. So that's 1 over 200. And then 10, 3 times 10 would be 30. 10 cubed is 1,000, so plus 1,000 over 3. Minus, and then it's just going to be 0 when you plug 0 into each one of those. So that's 1 over 200. That'd be 90 over 3, so 1,090 over 3. So that's going to be 1,090 over 600, which we can get rid of one set of zeros. So that's 109 over 60. So what are our units? Okay, well, the radius is going to be in inches. So don't try to simplify any further. I don't even know if you could. But the hard part, that's you can do that. Okay? And you want to get some of the, even if you mess up on the math, you want to set it up right, because if this problem is worth 2 points, you could easily get a point just for setting it up right. Okay, I'm going to erase that one. Let's do part B. So part B says find the volume of the funnel. Okay, so what we have to do to get the volume is add up the areas of all these red circles from 0 to 10. So from 0 down here all the way to a height of 10. Okay, so we would have volume. What's the area of a circle? Well, it's pi r squared, right? So I'm going to go ahead and bring that pi out front, 0 to 10, and then we'd have 1 over 20 times 3 plus h squared, all of that squared. So that's the radius, pi times radius squared. So here's where the math comes in, all right? 1 over 20 squared would be 1 over 400. So let's bring that out front. We've got pi over 400. And then that 3 plus h squared, I'm just going to, let's at the bottom here, let's FOIL that out. So 3 plus h squared times 3 plus h squared. So because we're squaring it. So that will be 9 plus 3h squared plus another 3h squared plus 6h squared plus h to the 4th. So I'll write that up here. 9 plus 6h squared plus h to the 4th dh. Okay, so you see how I got all that, foiled it out, foiled this part out. It was easier just to bring that, square that 1 over 20 and bring it out front. Okay, now this isn't so hard to integrate. Pi over 400 times, all right, 9h plus, we know we've got an h cubed, so I'd need a 2 out front. That gives us 6h squared if we go backwards. Plus 1/5 h to the 5th. We'll evaluate that from 0 to 10. It's a lot of mental math here. All right, pi over 400. The key is not to worry too much about simplifying it. Just, okay, that's going to be, first of all, the second one is going to be all zeros, so that's helpful. 10 times 9 would be 90, plus 10 cubes is 1,000, so 2,000. 10 to the 5th, okay, well 10 to the 4th is 10,000. 10 to the 5th would be 100,000. So that's 100,000 over 5, which is 20,000. So this one was a little bit mean from a mental math standpoint. All right, and then minus 0. So that's going to be pi over 400. So pi times 22,090. Over 400. So I could get rid of 1 0. And I would not try to simplify anymore. I don't even know if you can. 2209 pi over 40. Okay, they do care about the unit. So we're in inches. So what would be the unit for volume? It would be inches cubed. All right, there you go. So, yes, a lot of work, but doable work. Don't skip the ones you can do. Just dive right in there and do them. Okay, I'm about to erase this. And then part C says the funnel contains liquid that is draining from the bottom. At the instant when the height of the liquid is 3 inches, the radius is decreasing at a rate of 1/5 inch per second. At this instant, what is the rate of change of the height of the liquid with respect to time? So this is related rates. What do we want? The rate of change of the height. So that's dh dt. What do we know? Well, we know dr dt. It's decreasing 1/5 inches per second. So that's minus 1/5. And we relate what we want to what we know. Well, we do have an equation for this. It's r is equal to 120, 1/20th times 3 plus h squared. Okay, so I'm going to go ahead. It'll be a little easier if I go ahead and distribute that 1 over 20. So that'd be 3 over 20 plus h squared over 20. And we're going to differentiate that with respect to time. So we have dr dt is equal to, well, 3 over 20 is just a constant, so that goes away. So this would be 2h over 20 dh dt. All right, so that's going to be dr dt is equal to 2h over 20 is h over 10, right? h over 10 dh dt. All right, so solving for dh dt, which is what we want, that's dr dt over h over 10. We know dr dt. All right, we need to get h. All right, well, it gives us that in the problem. It says h is equal to 3. So we don't have to do any calculations there. what we need is given in the problem. So that dr dt is -1/5. H is 3 from the problem, so divided by 3/10. That's -1/5 times 10/3, which is -2/3. And that's inches per second, right? Height is in inches, rate of change in seconds. So -2/3 inches per second. A problem that's doable, but does take a while. Okay, so number 5, you get on these problems about 15 minutes a problem. Might be tough to get all 3 in 15 minutes. Okay, but certainly a problem worth practicing because you could get certainly part A and part B in 15 minutes. All right, I'm going to erase this and we'll try number 6. On number 6, you are given a table. And everything you need to know is in that table. So I'm not going to write the table out again. You just follow along with your printout. But I will be referring back to it. Okay, so 6a. It says that k of x is equal to f of g of x. Write an equation for the line tangent to the graph of k at x equals 3. Well, we need to figure out first k of 3. And then we also need to get a slope. Okay, remember our tangent line equation, y minus y1 is equal to the slope times x minus x1. We've got x1, it's 3. Let's get y. Okay, so to get that, we need to find k of 3. Okay, that's equal to f of g of 3. What is g of 3 from the table? All right, g of 3, if you'll look at the table, see the g of x column, it's the third one. G of 3 is equal to 6. So that's f of 6. What is f of 6? We'll find f, that's in the first column. F of 6 is 4. So that's our y1 value. Now the slope. The slope at 3 is going to be k prime at 3. So first of all, we got to get k prime of x, and then we'll plug in 3. Well, if k is equal to f of g of x, this is a chain rule. The derivative would be f prime of g of x times the derivative of the inner function, so times g prime of x. So that's chain rule. So k prime of 3 is f prime of g of 3 times g prime of 3. All of these numbers are in the table. Okay, so that's f prime. What is g of 3? We've already figured that is 6. And what is g prime of 3? All right, looking at the table, g prime of 3 is 2. F prime of 6 is 5. So that's 5 times 2. So our slope is 10. Convoluted, but really kind of easy if you can, wade through it. So our tangent line equation is going to be y minus y1. We figured that was 4. Y minus 4 is equal to our slope 10 times x minus 3. Okay. Not so hard if you just concentrate on the process. Okay. It's pretty common to have an AP free response question emanate from a table like this. Okay. Let's do part B. Part B says, let h of x equal g of x over f of x. What is h prime of 1? This one I think is a little easier than the last one. First of all, we've got to get h prime of x, and this is a quotient rule. So it's the bottom, f of x, times the derivative of the top, g prime of x, minus the top, g of x, times the derivative of the bottom, f prime of x, all over the bottom, f of x, all squared. So we got to plug in the number 1 there. All right, so we've got f of 1 times g prime of 1 minus g of 1 times f prime of 1 all over f of 1 all squared. Okay, what is f of 1? It's negative 6. What is g prime of 1? It is 8. Okay, what is g of 1? It is 2. Going right straight from the table. What is f prime of 1? It is 3. And f of 1 we've already figured out was negative 6. Got to square that. So that's going to be negative 48 minus 6, which is negative 54 over 36. They're probably going to want you to reduce that. I would hate to make a mistake here, but 9 will go into both of those. So that would be, in fact, I guess 18 would go into both of those. So that'd be negative 3/2. I'd be tempted to just circle that if your reduction skills are not super great. Okay, that's part B. All right, gonna erase that. Let's finish this thing up. Part C says evaluate 1 to 3 f double prime of 2x dx. Okay, I'm going up a level from f double prime. If I integrate that, that goes up to f prime, right? F prime. So the 2x there, if we did a u substitution, if u is equal to 2x, du is equal to 2 dx, so 1/2 du is equal to dx. So I know I'm going to have a 1/2 out in front of the answer. So 1/2 times f prime of 2x would be my answer. And we've got to evaluate that. That's the antiderivative. And from 1 to 3. So that's going to be 1/2 times f prime of 6. 3 times 2 is 6, minus 1/2 times f prime of 2 times 1, so 2. Okay, that's 1/2. F prime of 6 is 5. F prime of 2 from the table is negative 2. That's 5/2 plus negative 1, or 2 over 2, which is 7/2. That completes the 2016 free response. Good problems, a lot to learn from this video, so just keep watching and keep practicing.